This is the yogurt maker that I used in my video where I make homemade yogurt. And I'm pretty sure I mentioned in that video that this is actually the second yogurt maker like this that I currently own. I found this one at Goodwill, at my local Goodwill, for like $3 or $4. And it's exactly like the one that I bought previous to that on Amazon. So since I have an extra one, I thought maybe this could be a good way to incubate petri dishes. So I tested it out with some petri dishes and some liquid culture samples. You can see here, let me take the top off, that you can fit a pretty decent amount of these petri dishes in here. And that could, I'm gonna go ahead and say that you could probably fit about close to 20 or 30 petri dishes in this thing. And that would be amazing if you could just use this as is, but of course nothing is that simple. And the problem with this yogurt maker is it uses a heating element, obviously, to get this up to the temperature that you need to incubate yogurt. But yogurt needs to incubate at a temperature approximately like 109, 110 degrees Fahrenheit. And that's just way, way, way too hot for pretty much anything besides yogurt that you'd want to grow on petri dishes. So I want to see if I can put a temperature controller on this. Let me show you. Let me open it up and show you how this works. See, this is actually a really, really, really simple circuit. It's literally just the power coming in, the 120 volt power comes in through here, goes to a little light right there, and there's the on-off switch. And then these two wires here go to the heating element, and I don't even see like a thermal resistor or well, I guess it'd be a thermistor or anything. I don't know if it just maybe the heating element is rated to, at this length, put out a certain amount of heat, which I don't know, man, but there is no way of simply swapping out something in the circuit in order to make it go down to a lower temperature. But I have an idea that I think will work quite well. I've used these little modules before here. They're actually a really nice temperature sensing module that you can put a set temperature in for this to either turn on power whenever it reaches a certain temperature or turn off power once it reaches a certain temperature. And it actually works really, really well. So I thought maybe I could incorporate this into this guy here, and then I would have really, really accurate and really easy temperature control. So let's see here. Yeah, it needs 12 volts DC to power. That's fine. I'll just put a 12 volt DC supply to go in here, and then all I need to do is just use this as a switch for the heating element on here. So once this reaches the desired temperature that I have set on this little module, it'll turn off the heating element, and then it'll stay at that temperature until it starts cooling down, after which it will actually turn it back on. The heating element will heat up again, and it'll bring that back up. So it should stay in that temperature range that I set it at. So yeah, that should be a fairly simple way to do this. So let me get this incorporated and I'll show you if it's working, okay? I'm going to use this little AC to DC LED driver that I have. It seems to knock the 120 AC voltage down to about 35-ish DC, and I can work with that. The only thing is I have to be extremely careful because this is live AC power, and right on the underside of the module is also live AC current. So I'm going to, after I get this set up, I am going to spray that with insulating spray liquid electrical tape, because that be scary. But I think we're on the right track. I think I have the 12 volt supply for the module figured out. I can tap into the 120 volt AC power that goes into this thing. That can go to this little LED driver that kicks the 120 volt AC down to 35 volt DC, and then the 35 volt DC can go into this little buck circuit, which I have it tuned to put out about 12 volts, 12.1, 12.0 volts. That's not gonna hurt anything. So I think this is good as far as the power supply goes. Let me plug my little module that I have into this. Let me wire this up and see if the module turns on okay. It should, but we'll see. And since this is live AC, I'm being very careful because I do not want to die from this. So let's wire that up carefully and then go from there. Oh, and in case this does blow, in case this somehow does ruin this module, these are only $4, so I bought 4 of them just to have more on hand. Hopefully I don't break it, but if I do, I still have 3 to fall back on, and I can figure out a better way to do this. But I think this will work. I don't have the power turned on to this plug yet. So 120 volt AC goes into the LED driver, which kicks that down to 35 volt DC on the output. That output then goes into a buck module, which I have tuned to put out 12 volts DC, which is then wired into my little thermal sensing module here. And hopefully, whenever I turn the switch on to the power bar there, this will turn on. So let's see, it's either going to turn on or things are going to blow up. Either way, it's going to be fun. So, yep, we're good. Hey, all right. So, yeah, that seems to like it'll work pretty well. Yeah, that's not hot at all. I'm not touching anything on this one at all. Because I may be stupid, but if there's one thing I am not, sir, that is stupid. So, yeah. This seems to work just fine. The nice thing about these modules is they do not draw a lot of current at all. So these don't have to put out a whole lot of power in order to drive this. The only thing this is acting as in this circuit whenever we're going to put it into our yogurt maker is this is going to basically be an electronically controlled and thermally controlled switch that will turn on and off the heating element on the yogurt maker. Okay, let me figure out how I'm going to do this without killing myself. I know this looks kind of like a mess, but it's actually fairly straightforward. Here is the AC lines that are coming in. One of them, let me move this out of the way. One of them goes straight to the heating element. Well, it's supposed to. But I have that spliced off to this red wire, the end of the red wire, and the other end of the wire that will be going to the heating element is spliced into this black wire right here. These 2 wires go to the temperature sensing module to power it from 12 volts. There is the LED driver, which is then fed into a buck converter, and that'll keep it a nice steady voltage even if the voltage fluctuates a little bit. And like I just said, the output to the DC to DC converter is right here to power the module, which is right here. And this wire is for the temperature sensor, which is this wire right here, fed up through a small hole here on the side. And I'll just have it sticking out. I'll just have a piece of foil tape on there to keep it as flush as possible. Or maybe I'll just do this. That might be better just to do that to keep a better internal temperature of the... I guess this is now officially a Petri dish incubator instead of a yogurt maker. And that should sense the internal temperature of this shell itself instead of... I was thinking of maybe just putting the temperature sensor on the underside of this, but I don't think that would work all that great because this is going to get hotter a lot quicker than this will. I don't want this temperature sensor to shut the heating element off until the inside of the actual incubator itself has reached the desired temperature. So I think maybe taping with some foil tape the temperature probe right here to the side will keep it out of the way, but that'll also give a better internal reading of the temperature in this chamber here. I think all I need to do now, I need to heat shrink. I already have the heat shrink tubing put on here, but I need to shrink this heat tubing down so that nothing shorts out. I did spray some spray-on electrical tape on the underside of this. I put some hot glue down on the bottom of the module to insulate it from the bottom, but also to, obviously stick it down. This one's hot glued down as well, just so it doesn't go anywhere. All of the exposed wiring is covered up that wasn't already exposed to begin with, so these ones here are the way it was whenever I bought it. And I also wired it in such a way to where all this is only going to come on whenever I actually turn on the main power switch. That way I'll still have an on and off switch for the whole system, and I don't have to worry about it, like shorting anything out if it's left plugged in. So as long as this button is off, the whole thing is off, including the module itself. So I guess now I need to wire this up and attach it to the side. For now, I'm probably just going to hot glue it just so that I can kind of get a proof of concept going. Maybe later on, after I work out the bugs, tweak this a little bit, maybe I will actually like screw this onto the side. But for now, I'm just going to hot glue it in order to get it on the side there for proof of concept testing. So let me get it set up and we'll take some temperature readings and see how that works. Alright, I have all the necessary connections made. The yogurt maker is back together. All I need to do now is tape this temperature probe right here. I'll do that here in a little bit, but I want to plug the yogurt maker itself in and see if it turns on, and hopefully this turns on. This is what I want to turn on. So, fingers crossed. Here we go. Ah, yes. It turned on just fine. So let me see. Is the temperature probe on? Yep. Grab the temperature probe, it's going up in temperature, so that seems to be working great. Alright, I guess all that's left to do is to tape this to the side here and program this at a set temperature and then run a data log temperature sensor on it to see what temperature this maintains. I do want to add that I'm also going to put some hot glue over these little pins right here, like these through-hole pins that go to the connectors here on the temperature sensing module, just because these two over onto the far right here are the ones for the actual heating element, like that switch off the heating element. And while it is only one of the phases of the AC signal, that's still AC right there, and I don't want that to be exposed. So I'm going to put a little bit of hot glue. I'm going to put a nice big glob of hot glue over that just to isolate it from being able to accidentally be touched. I have the temperature controller module ready to go. I have this set for 30 degrees Celsius, and that is hooked up to my incubator. The incubator is plugged into the wall over here, and I actually have a temperature probe kind of floating in about the middle-ish of the incubator itself, and that temperature probe is hooked up to a USB data logger, which is connected to this program, which I can see the data curve for the temperature log that this is going to be putting out to see if I get a nice gradual curve, and then hopefully it plateaus off and it stays at around 30 degrees Celsius. It's okay if it goes a little bit, like a degree or two here or there, but if it goes, like I don't really want that. I want that to be as flat as possible. Oh, and as you can see, whenever I am doing something like this out here in my shed, if I'm not talking on camera, I'm watching usually the Angry Video Game Nerd. I'll have him on the background, and I just like to put his season compilation videos on. I'll just let those go off in the background as I'm doing my thing out here. But anyway, let's turn this yogurt maker on. That turns on the heating module, which it is 28.7 degrees Celsius on. The red light here indicates that the heater in the yogurt maker has turned on. I guess now we just wait to see if this reads approximately 30 degrees or so. Let's give it a half hour, say, and then see how it looks. It's actually been about 45 minutes, and as you can see, the temperature isn't perfectly steady. Ever since it kind of got to this point, it does fluctuate by a degree or two, but it's only like 1 or 2 degrees Celsius. It's actually pretty good, and it's maxing out at about 29, and that is with I moved the temperature probe to be just touching the bottom of the incubator to see what that would register on the temperature sensor. And honestly, I'm actually really happy with this result right here. I think this will be very similar to like a refrigerator, to where a refrigerator is actually more efficient and it's better at maintaining its temperature if there's more items in that refrigerator kind of to hold that thermal mass. Well, I think the same could be true for this incubator right here. The more petri dishes I have in here, I think it will actually make this be a more steady temperature range. Even if it does fluctuate like it is on here, I'm perfectly happy with a homemade incubator that I got at Goodwill for $4 with maybe $7 worth of components soldered into it and added into it. I think this is going to work just fine for my purposes because I'm doing things at home, so things at home are very rarely ever ideal. But as far as doing things at home, I think this is about as good as I'm going to get with something as homemade and thrown together as this thing is. So yeah, I think this will be a really, really good way to incubate some petri dishes without having to take up real estate in my actual incubator. I do have a hole drilled in the top here for air exchange and airflow. That way it just has a little bit of fresh air exchange to give extra oxygen to the things that are going to be in here. The only things I want to do is I want to put something on the bottom of the incubator, like the inside, like maybe some plastic shelving grid, like to just kind of provide a little tiny thin barrier between the bottom of the incubator and whatever I have in there. And I also want to get some black plastic spray paint and spray paint this lid like a dull black. I don't want it to be a shiny black. What's the word I'm looking for? Oh my gosh. You know what I mean. I want it to not a matte black. I want this to be a matte black, and I don't really want any light to get into here. So if I paint this a matte black finish, I think that'll be the final touches to turning this into a really nice little homemade incubator for my petri dishes. And like I said, I should be able to get like 25 or so of those petri dishes in here. Maybe, probably about 20, I'd say maximum, if I use the 90mm ones. And if I use the 60mm ones, I could probably get like 30 or so in here. I'll make an update on this video here whenever I actually put it to some use in the upcoming weeks or months or whatever, and tell you how it worked out. So I'll see you guys next time. Thank you for watching, and let me know what you thought. Bye-bye.